Imagine a civilization that didn't merely look at the stars, they spoke to them, leaving behind evidence that suggests their messages were far more than mythology or ritual. Archaeologists have long debated whether ancient humans could comprehend cosmic distances, encode information in ways we would recognize today, or perceive time beyond the linear, survival-driven perception of their immediate environment. Yet, a series of discoveries in the last decade challenge the assumptions we hold about the cognitive and societal sophistication of early civilizations. Across the remote highlands of a forgotten continent, researchers have unearthed artifacts that encode patterns remarkably consistent with astronomical cycles, patterns that imply not just observation, but deliberate communication, a form of proto-astrolinguistics, and a collective attempt to understand humanity's place in the cosmos. These findings force us to ask a question that has lingered in the shadow of scientific imagination. What does it mean when a society, long vanished, reaches outward toward the stars? And how do we, as modern humans, interpret those signals through the lens of psychology, neurology, and social dynamics? At first glance, these artifacts might appear as mere geometric carvings or abstract inscriptions on stone and metal. However, when examined with the precision of modern astronomy and neurocognitive analysis, they reveal a sophisticated understanding of celestial movements. One example is a series of tablets found in a subterranean chamber, etched with interlocking spirals, and sequences that align precisely with the cycles of Venus, Mars, and the Moon over decades. These sequences are not random. They correspond to observational data that would require generations of meticulous record-keeping. From a psychological perspective, this suggests that these people developed collective attention spans far beyond what we usually attribute to hunter-gatherer or early agrarian societies. Their cognition, distributed across the social network of the community, reflects what modern neuroscience might call an extended working memory, where knowledge is embedded in communal artifacts rather than confined to individual brains. The implications are profound. If we consider the brain as a system designed to detect patterns and respond to environmental stressors, then this civilization demonstrates a remarkable adaptation of those neural processes to social and cosmic contexts. Their perception of time and space was malleable, stretching beyond immediate survival imperatives to a form of strategic foresight. They encoded survival not only in food storage and defense, but in knowledge of celestial mechanics, effectively creating a temporal map that could guide generations. Their society functioned as a living neural network, where knowledge flowed between individuals, artifacts, and the environment in a feedback loop reminiscent of modern distributed computing. One could imagine their communal decision-making as analogous to neural ensembles. Each participant contributes partial information, yet the emergent structure exhibits intelligence far beyond any single contributor. But why speak to the stars at all? From a philosophical standpoint, it appears that this civilization recognized the limitations of the individual perspective and sought to externalize cognition. The sky, vast and unchangeable, becomes a canvas upon which human understanding can be projected. In doing so, they were not merely observing. They were communicating across time, encoding messages meant for descendants who might inherit the task of interpreting the universe. The artifacts themselves act as a mnemonic scaffold, a memory palace etched in stone and metal that allows successive generations to read cosmic phenomena in the same way that neurons encode patterns of experience. The society's structure, centralized yet distributed, hierarchical yet cooperative, appears optimized to maintain and transmit these signals, indicating a deep understanding of social resilience and the psychology of knowledge retention. From an evolutionary perspective, this approach challenges the conventional narrative of technological progress. Typically, we assume that complex astronomical knowledge emerges only after urbanization, literacy, and intensive specialization. Yet the evidence suggests that these people achieved what modern anthropologists might call cultural computation long before they had written language in the conventional sense. Their cognitive processes were not constrained to individual neurons. They offloaded memory, calculation, and pattern recognition onto social structures and material culture. This is analogous to using external hard drives in modern computing. The society itself became an information processing system, capable of modeling celestial dynamics with precision and transmitting that knowledge across centuries. Such distributed intelligence requires trust, cooperation, and shared attention, the very foundations of what psychologists now identify as collective intelligence or group cognition. The artifacts also hint at a sophisticated understanding of cause and effect on a cosmic scale. Several stone spheres meticulously aligned with lunar and solar eclipses suggest that these people not only recorded events but anticipated them, effectively predicting celestial phenomena decades in advance. Neurologically, this requires the abstraction of temporally distant events, the manipulation of mental models of motion, and the projection of consequences beyond immediate perception. From a social standpoint, it indicates a shared narrative that enabled collective planning, ritualized coordination, and perhaps even governance based on cosmically informed principles. These insights transform how we understand early human intelligence, not merely reactive or practical but anticipatory, symbolic, and profoundly integrative. Yet perhaps the most striking element is the evident language of the stars. Unlike written scripts that rely on arbitrary symbols, these communications are intrinsically tied to natural rhythms, encoded through geometry, rhythm, and recurrence. Neurologically, this is fascinating because it mirrors the way the human brain processes patterns. Spatial, temporal, and numerical information are interlinked in cortical circuits responsible for memory, attention, and prediction. The civilization's artifacts may have acted as an external cognitive prosthetic, extending neural capacities beyond biological limits and enabling complex collective reasoning. In other words, by encoding messages in the cosmos, the society effectively offloaded cognitive load, freeing individual brains to engage in innovation, social organization, and ritualized behavior. Their collective intelligence becomes legible to us only because it aligns with universal perceptual and cognitive structures. A particularly compelling example is a series of subterranean alignments where stones and carvings indicate an understanding of synodic cycles, orbital resonances, and periodicity in a manner that anticipates the development of celestial mechanics by millennia. These alignments are not only precise but also encoded with symbolic elements suggesting moral and social directives. From a psychological perspective, these artifacts may have functioned as regulatory signals, subtly guiding behavior by linking individual action to cosmic cycles. Imagine a society where the rhythm of work, ritual, and governance is informed by celestial feedback loops. Stress responses, often viewed as reactive, would have been modulated by anticipatory knowledge, reducing uncertainty and enhancing social cohesion. In essence, these people may have built a civilization that psychologically synchronized with the cosmos. One might ask whether these interpretations risk anthropomorphizing celestial phenomena or projecting modern cognitive models onto ancient peoples. Certainly, skepticism is warranted. Yet the consistency of patterns across multiple sites, the convergence of archaeological, astronomical, and neurocognitive evidence, and the durability of these artifacts through time suggest intentionality that transcends mere coincidence. In modern terms, we might describe this as a system exhibiting emergent intelligence. Individual components, human actors, tools, symbols interact to produce outcomes that cannot be reduced to single causes. The civilization's artifacts act as nodes in a network, each piece reinforcing, correcting, and amplifying others, resulting in a coherent knowledge system capable of predicting and responding to cosmic dynamics. This approach challenges our assumptions about the limits of early human adaptation. Modern neuroscience demonstrates that stress, uncertainty, and perceived scarcity trigger survival-oriented neural circuits, often at the expense of higher-order cognition. Yet here, we see a society that transforms environmental and existential stress into a catalyst for collective intelligence. By projecting attention outward toward the stars, they externalize anxiety and convert it into pattern recognition, long-term planning, and social regulation. In other words, what might appear as vulnerability or obsession with the unknown is actually a protective mechanism, enhancing group survival and cognitive capacity. The very behaviors that seem irrational in isolation emerge as adaptive strategies when viewed through the lens of collective neuropsychology. Moreover, these discoveries compel us to reconsider the relationship between culture and perception. If perception is not merely sensory input but an active construction informed by social and environmental context, then these artifacts demonstrate that entire societies can cultivate a shared perceptual framework. They train themselves across generations to perceive temporal and spatial relationships that our own cognition struggles to apprehend without technological augmentation. This implies a form of cultural neuroplasticity. The environment and communal practices literally shape the way brains encode and interpret information. The civilization's engagement with the stars was not a passive observation, but an active sculpting of cognition itself, a deliberate extension of mental horizons through communal practice. Yet despite these advances, the civilization ultimately vanished. Natural catastrophes, ecological shifts, and societal fragmentation likely disrupted the delicate balance of attention, memory, and social cohesion. Here lies a paradox. The very structures that enabled extraordinary cognitive feats were also fragile, dependent on sustained collective effort and environmental stability. Neuroscientifically, this illustrates the interplay between resilience and vulnerability. Systems that extend cognition into the material and social environment gain power but also acquire points of failure. Distributed intelligence can outperform individual reasoning, yet it remains sensitive to perturbations. In the ruins, we glimpse both the brilliance and the precariousness of collective human ingenuity. The story does not end in desolation, however. Modern researchers, by decoding these artifacts, participate in a form of cognitive resonance with this lost society. Each spiral, alignment, and etched pattern invites us to engage not just intellectually but neurologically, aligning our attention with a mental schema evolved for astronomical reasoning. In doing so, we experience a rare cognitive empathy, understanding a worldview that is at once alien and remarkably coherent. Philosophically, this challenges assumptions about human temporality, agency, and knowledge. If a society can project intention across centuries, then our conception of legacy, memory, and influence expands to encompass networks, symbols, and structures, not merely individual acts. The stars become not only a physical horizon but a cognitive mirror, reflecting capacities latent in every human society willing to attend, encode, and transmit knowledge collectively. Perhaps the most humbling realization is the continuity between their cognition and ours. While their tools, materials, and symbols differ, the underlying neural architectures, the capacity for pattern detection, abstraction, memory consolidation, and social learning are fundamentally the same. What differs is the environment, the structure of social transmission, and the intentionality of long-term planning. In this sense, the artifacts serve as both mirror and teacher. They reflect the potential inherent in human networks and demonstrate what can be achieved when cognitive, social, and environmental systems align. The civilization's message to the stars is ultimately a message to ourselves. Our minds, extended through culture and technology, can perceive, encode, and influence far more than our immediate sensory environment suggests. As we confront these findings, we are confronted with profound questions. How much of our own cognitive potential remains untapped because it is constrained within individual brains rather than extended into collective networks? To what extent can modern societies, with their technologies and social media, learn from a civilization that externalized cognition to communicate with the cosmos? And what does it mean that the structures we now call knowledge, science, and culture are themselves extensions of neural architecture, evolving in dialogue with both material and celestial environments? Each artifact, each alignment, each spiral is a node in a historical and cognitive network, a reminder that the pursuit of understanding is not linear but distributed across generations, materials, and minds. The story of a civilization that spoke to the stars teaches us that intelligence, adaptation, and resilience are not confined to survivalist pragmatics. They emerge from collective attention, iterative knowledge transmission, and the willingness to engage with phenomena that stretch beyond immediate perception. In essence, by reaching for the stars, this society transformed stress, uncertainty, and curiosity into mechanisms for cognitive and social enhancement. Their legacy challenges us to reconsider the boundaries of human potential. Perhaps intelligence is less about individual brilliance and more about networks, memory, and the deliberate extension of mind into the world. In conclusion, the literal evidence of this civilization as communication with the cosmos invites us to rethink not only the history of human cognition, but the philosophy of perception itself. Their artifacts, preserved against the erosion of time, embody principles that are as relevant today as they were millennia ago. That knowledge can be distributed, memory can be externalized, and intelligence can operate on scales that exceed the individual. By studying them, we are not merely decoding symbols. We are participating in a dialogue that spans time, space, and consciousness. It is a humbling reminder that our own capacity for understanding, like theirs, is shaped by the structures we build, the societies we nurture, and the attention we devote to the vast, silent, and endlessly intricate universe around us. If this exploration has sparked your curiosity, take a moment to reflect on how your own society, networks, and personal practices might extend your cognitive reach. Could you, in some small way, participate in a network of understanding that transcends your immediate perception, leaving signals for future generations? If you found this journey through time, cognition, and the cosmos enlightening, make sure to like this video, share your thoughts in the comments below, and subscribe to Past Lens to continue exploring the hidden layers of history and human potential. The stars may have guided a lost civilization, but they continue to invite us to expand the horizons of knowledge, perception, and imagination.